Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the important concepts of inclined plane and important advice. Be soft, be kind, and be humble. Given that this object is at rest on this inclined plane, which is inclined to an angle theta from horizontal. This is the weight of the object because weight always acts vertically downwards. It makes 90 degree with the ground. And the formula of weight is mg. When you resolve weight into its components, you will get two components. One component is parallel to slope and down the slope, and the other component is perpendicular to slope. And these directions are according to head to tail rule. This is the opposite of this triangle, whereas this is the adjacent of this triangle. This component of weight is always in terms of sine theta. So this must be W sine theta. W means mg. And this component is with theta, therefore it must be in terms of cos theta. So it's W cos theta or mg cos theta. These two angles are always equal, and we can prove them by using angle properties of straight lines. See, this component, to make the force diagram simple, we can make this component here. I mean, they both mean the same thing. And this is the normal reaction. Normal reaction always makes 90 degree with the slope. Case 1. The object is moving up the slope by applied force FAP, where FAP is parallel to slope. See, this is weight and this is the component of weight which is parallel to slope and down the slope. And this is the component of weight which is perpendicular to slope. And this is the normal reaction. And this is the frictional force. You all know friction always acts against the motion. So in order to move this block up the slope, or to move this block up the slope, this force must be greater than sum of these two forces. This is here. F applied greater than mg sine theta and friction. Since there is no motion of the object perpendicular to slope, therefore R must be mg cos theta, because no motion perpendicular to slope. This is the way to draw the force diagram and write down the equations. Case 2. The object is moving down the slope by applied force FAP. Let me just correct the direction of this. This is the situation. The object is moving down the slope by the applied force FAP. So this is FAP, this is mg sine theta, mg cos theta, friction. Since this object is moving down the slope, therefore friction must be up the slope. So FAP and mg sine theta both must be greater than friction when this object is moving down the slope. And since there is no motion perpendicular to slope, therefore R is equal to mg cos theta, which is here. You all know how to simplify this. When you will bring friction on left side, this will become MA. Like mg sine theta plus F applied minus friction is equal to MA, because this is net force and net force is always equal to MA according to Newton's second law. Case 3. The particle is projected up. When it says projected up on the line of greatest slope, then applied force is always 0. So the particle is projected up means applied force is 0 on the line of greatest slope. So this is 0. To make the resolving simple, I just mentioned this here so that you can easily form this inequality. So object is moving here up the slope because it is projected up the slope. So F applied must be greater than mg sine theta and friction. But since object is projected up the slope, therefore F applied must be 0. Friction mg sine theta ma. So you need to use this equation. Since there is no motion perpendicular to slope, therefore R must be mg cos theta. When you resolve forces perpendicular to slope, then R is mg cos theta. And particle or object, sorry, the particle is decelerating because u is greater than v. U is the velocity of projection. The object is projected with initial velocity u. Case 4. The particle P slides down, means applied force is 0 on a line of greatest slope. So this component of weight mg sine theta is responsible for this particle to move or slides down the slope. So mg sine theta must be greater than friction. So with the help of this inequality, you can form this equation and you can easily solve this equation with this equation for the unknown to get the values of unknown constants. This is the second equation. R is equal to mg cos theta. And you all know the formula of friction. If it says limiting equilibrium, then always use this formula. This formula is used when the particle is in limiting equilibrium. Case 5. The object A is moving up the slope by applied force FAP, which is parallel to horizontal. Now this is very important. The applied force is parallel to horizontal, which is here. See, this applied force is parallel to horizontal. So we need to resolve this applied force. There are two components of this applied force. One is parallel to slope and the other one is perpendicular to slope. And there are same inclination. This is parallel to slope. So this angle and this angle must be same. If this angle is theta, this must be theta because this component of applied force is parallel to slope. So there must be same inclination. So this is adjacent of triangle. Therefore, this should be FAP cos theta, whereas this is opposite of this triangle. So this must be FAP sin theta. FAP means applied force. This is the normal reaction. Normal reaction always makes 90 with the ground, sorry, with the slope in this case. And this is mg cos theta. And this is mg sin theta. These are two components of weight. And this is the frictional force because the object is moving up the slope. So in order to move this object up the slope, this force must be greater than sum of these two forces. FAP cos theta must be greater than mg sin theta and friction to move this block up the slope. R, this is the normal reaction force. So R is equal to FAP sin theta and mg cos theta because these two forces are acting in downward direction and this one is acting up the slope, perpendicular to slope and in upward direction, and no motion perpendicular to slope, so we must have equal sign here. make sure you draw the force diagram correctly and you resolve this F correctly. Case 6. The object A is moving down the slope by applied force FAP, which is parallel to horizontal. Same thing, same case. Here, the applied force is parallel to ground, horizontal, and the object is moving in this direction, up the slope. Now, the applied force is here in this direction, and this object is moving down the slope. And applied force is still parallel to ground. So again you have to resolve this applied force. So there are two components of this applied. One is parallel to slope and the other one is perpendicular to slope. And these directions are according to head to tail rule. So this is FAP sine theta, this is FAP cos theta, because this component of applied force is with angle theta, so it must be in terms of cos theta. This is the normal reaction, which is perpendicular to slope. These are two components of weight, and frictional force is in this direction, up the slope. So to move this object down the slope, this FAP cos theta and mg sin theta must be greater than friction. And since there is no motion perpendicular to slope, therefore R plus FAP sin theta must be mg cos theta, must be equal to mg cos theta. Case 7. The applied force FAP is just sufficient to prevent the object from moving down the line of greatest slope, where F applied is parallel to horizontal. See, this applied force is just sufficient to prevent the object from moving down the line of greatest slope. So this force is sufficient to hold this particle here, this object here. I mean, if this object will move, it will move down the slope. So friction must be up the slope. So whenever it says to sufficient to prevent the object from moving down the line of greatest slope, that means friction must be up the slope. The resolving is simple. We already have done this resolving in case 5. This component of applied force is parallel to slope. So it must be FAP cos theta, this is FAP sin theta, and these directions are according to head to tail rule. So FAP cos theta plus friction is equal to mg sin theta. Why we have equal sign? Because it's just sufficient to prevent the object from moving down the slope. This means the object is in equilibrium. So that is why we have equal sign here. And this R is equal to FAP sin theta plus mg cos theta, because there is no motion perpendicular to slope. The most important thing of this case is the direction of friction. It says moving down, so direction of friction should be up the slope. Case 8. The applied force is just sufficient to prevent the object from moving down the line of greatest slope, where F applied is parallel to slope. Now in this case, applied force is parallel to slope. In the previous case, the applied force was parallel to ground. So case 8 is simple. This is the applied force, frictional force is here. So sum of these two is equal to mg sin theta, because the object is in equilibrium. And you all know R is mg cos theta, because no motion is perpendicular to slope. Case 9. The applied force makes an angle alpha with the slope. This is the applied force and it makes angle alpha from the slope. And the object moves up the slope. So this applied force have two components. Number one, FAP cos alpha, and number two, FAP sin alpha. And these are the two components of weight. Since this object is moving up the slope, therefore friction must be down the slope. So this FAP cos alpha must be greater than sum of these two. And R plus FAP sin alpha is equal to mg cos theta. See, the most important thing is force diagram, the correct force diagram. If you can draw the correct force diagram according to given situation, you can easily write down this inequality and this equation. Case 10. The particle P moves or is projected up the line of greatest smooth slope. Now this is very important. Smooth means no friction. So projected up means applied force is zero. Whenever it says moves up or projected up, it means applied force is zero. Smooth slope means no friction. And the particle is projected up the slope with initial velocity u. So in order to resolve this easily, you should write FAP is greater than mg sine theta and friction. This is here. You can directly write this equation, but to understand how to write this equation, you should use this inequality. F applied is greater than mg sine theta plus friction. Since there is no friction, so you don't need to write friction here. You just need to write F applied is greater than mg sine theta. Since F applied is 0, so minus mg sine theta is equal to ma. Therefore, minus g sine theta is equal to a. So if you learn this equation for this motion, then the solution will be very simple for you. You can easily handle the situation. Otherwise, you have to draw this equation through this inequality. So whenever particle is projected up the smooth slope, always use this acceleration. A is equal to minus g sine theta. You can learn this. The particle, case 11, the particle P moves or is projected down the line of greatest slope. Just change the sign. This is minus, so use plus. A is equal to g sine theta. Because mg sine theta is greater than friction, since there is no friction, so equate friction to 0, you will get A is equal to g sine theta. So just learn this equation when particle is projected down the slope on the line of greatest slope. A smooth slope. This is for a smooth slope. This is all. Best of luck. An important advice for me and for everyone, we must be gentle to others. Allah Hafiz.